Okay, so for those of y'all who went to the junior talk this morning, I wanted to go ahead and make a screencast for y'all so that you could have the notes and be able to do the worksheet that will be due on Thursday morning at 7:30, and as always, submit it to Moodle. Okay, so what we're going to do today is that we're going to look at the history of the periodic table, and we're also going to look at the properties of the different categories or groupings of the periodic table. We have two major groups of the periodic table, metals and nonmetals. And then we can also break the periodic table down into different families. And so we're going to look at the properties of all of that. Okay, so of course, most people know that Mendeleev was the person who developed the first periodic table, and this happened in about 1869. And what he did is that he arranged the elements in order of increasing atomic mass. And he created columns with elements that had very similar properties to it. And he was absolutely so good at this that he could even tell where it was missing elements, where there were still elements that needed to be discovered. And so his periodic table was terrific, and it worked for quite a while. And I do recommend, after you watch the screencast, that you go back through OneNote and you watch these videos that I have embedded in here. They're really great. They give you a lot of interesting background information. After Mendeleev, Henry Moseley did the, I would say, refinement of the periodic table. And he looked at some X-ray spectra of the elements, and he discovered that it would be better to arrange the elements by their atomic number rather than by their atomic mass. And so this changed the arrangement of the periodic table somewhat. Now, Henry Moseley, I always call him our tragic figure of chemistry. Henry Moseley was an Englishman, and he did a lot of his work before World War I. World War I broke out, and he decided that he needed to enlist in the Army. And many scientists, many of the people he worked with, begged him not to do this, and he said, no, I need to go do my duty for my country. And he ended up dying in Turkey, in a battle in Turkey, and did not return to do even more work. And it's really unfortunate because he was so brilliant, and I think most scientists saw that he would have ended up winning a Nobel Prize if he had continued to do work in chemistry. And in fact, after his death, Britain changed their laws where scientists were not allowed to enlist and actually go out on the battlefields, and instead most of them stayed working in labs and creating things for the British government. All right, so as I said before, we can break down the periodic table into two main areas, and that is our metals and our nonmetals. And that nice little like stair that you have in towards the right-hand side of your periodic table, and those are called the metalloids, all those elements that touch there. That little stair, that little division is really what separates our metals from our nonmetals. And these two big groups on the periodic tables do have very different properties. Your metals tend to be shiny. They are usually very malleable and ductile, meaning that you can hammer them and you can stretch them. They're good conductors of electricity and heat. They have very high melting and boiling points. They tend to be very dense, and oftentimes they react with acids. Pretty much all your metals are solids except for mercury. Now, your nonmetals, on the other hand, tend to be just the opposite. Non-metals are dull in appearance. If they are solids, it tends to be brittle solids. They are poor conductors of heat and electricity, and they have low melting and boiling points. In fact, a lot of them are actually gases at room temperature. You do have a couple of them that are liquids, and then just a few that are solids. And they also have very low densities. So now let's look at each individual family of the periodic table and look at the properties for them. So alkali metals, this is your group 1 metals. This is the first column of the periodic table. Now this does not actually include hydrogen. Okay, so this is going to start with, I believe that's going to be lithium. Make sure I'm telling you right. Yes. So that's going to start with lithium and work down to francium. They have very low melting points, very low boiling points. They're soft. They can even be just cut with a butter knife. And oftentimes they react very vigorously with water, almost causing explosions. Now they do become less reactive as you move down the group. And once again, I do recommend that you watch these videos here. It gives you some interesting properties of different elements. For this particular video, it's on lithium, and it'll give you some interesting facts on lithium, and you can watch some reactions with it as well. Here is a picture of some of our elements, some of our alkali metals, where we have our lithium. And once again, we see that shiny color of them. And then we have sodium, potassium, rubidium, cesium, and francium. All right, let's move all the way clear across your periodic table to the halogens. So this is going to be, I believe, group 17 of the periodic table. And these are nonmetals, and they are not very reactive. And there, once again, reactivity decreases as you move down the group. Now, they do form diatomic molecules in their pure form. So what does that mean when we say that they are diatomic? Di means two. And so what we have here, so this is going to be, let's see, fluorine, followed by chlorine. Then we have bromine and iodine. And when we say that they are diatomic, what this means is that they are never really by themselves. They are always connected to what I always say is their twin. So that fluorine becomes F2, chlorine becomes Cl2, bromine becomes Br2, and iodine becomes I2. And we also see here with the halogens that we have some of them that tend to be gases at room temperature. Bromine, which I believe tends to be a liquid at room temperature. And then iodine, which tends to be a solid at room temperature. Once again, another great video on some of the properties of the halogens, and in this one on chlorine. Now, if we move over to the right one, we get to the noble gases. And remember, noble gases, why are they considered noble? Because they are unreactive. They don't need to form any kind of bonds with any other elements on the periodic table. They already have a filled valence electron, so they've got 8 electrons on that outer shell, and so they don't need to form bonds because they are perfectly happy and fine just the way they are. Our noble gases start at helium and work all the way down to xenon. So there are 7 periods on the periodic table. And your rows can also be called periods. And these are going to correspond to the number of energy levels of an atom. So we are already familiar that there are going to be 7 periods or 7 rows of the periodic table, because we know that there are 7 main energy levels. Now, our columns are oftentimes called groups or families. Groups or families. And our columns oftentimes correspond with the number of valence electrons. Now, this is true for our S block, and this is true for our P block, but our D block, those transition metals, those are a very special, and we will learn about those, but those do not correspond to, those numbers do not correspond with valence electrons. All right, so let's look at this valence electrons a little bit more. Now, the valence electrons are the most important electrons that are in an element, an atom. And the reason for that is that these are the electrons that can be lost, they can be gained, or they are shared between atoms. Valence electrons are located in the highest energy levels. And most often these energy levels are incompletely filled. So the only one that's happy, just the way it is, are those elements that are noble gases. Now, here is something that's really important that I want to make sure you understand. And that is right here. Okay, so that particular element that would be right there, hopefully you realize that that would be helium. And helium is very special because it is happy, it is full, only feeling 2, okay? The rest of our noble gases, which we see right here, okay? So this is going to be our neon all the way down to our radon. And neon down to radon, these are our more typical noble gases where they feel happy, are filled with 8 valence electrons. Helium, you need to memorize this, it is important. It is a little different because it only has, it's happy and filled with 2 valence electrons. So here are our alkali metals, and I'm just going to abbreviate since we don't have a ton of room. Here would be our alkaline earth. Let me see if I can get this in here. Alkaline earth metals. And then over here, this would be our halogens, which I don't think that's really showing up well. Let me try that again in red. Okay, so there's our halogens. These here, so this would be oxygen on down. These are sometimes called chalcogens. I don't know who comes up with this, but these are sometimes called chalcogens. So I'm just going to put a CH. Valence, so our group 13, 14, and 15, they don't have any kind of special name for these groups associated with them. So it's our valence electrons that are really doing all the work, because they are either being lost by an atom, or they're being, and those that are being lost by an atom are being gained by another atom, or they are being shared. And this is really, the valence electrons is what helps us form our chemical compounds. And once again, the vast majority of these atoms or these elements on the periodic table are trying to feel like one of the noble gases. They're trying to feel like an 8. And this is called the octet rule. They're all trying to feel a full valence electron of 8. And yeah, okay, so that finishes out the notes that I wanted to do today. And so your homework is to complete this worksheet And as always, make sure it's submitted to Moodle as a PDF by 7:30, let's see, Thursday morning.